Have you ever poured a glass of milk and just thought, well, it's milk, simple, white, and that's about it? What if I told you that inside that ordinary glass is an entire world of incredible science and seriously complex chemistry? Today, we're going to pull back the curtain on the secrets of milk, and I promise you, by the end, you'll see it's anything but simple. So let's start with that big question. Is milk really just a simple white liquid? I'm going to go ahead and say the answer is a big no. And by the time we're done here, I guarantee you'll look at that glass of milk on your breakfast table in a completely new light. So let's get into it. All right, first things first. What is milk really? Before we can get into its amazing journey from a farm to your fridge, we have to understand what it actually is on a fundamental level. You've probably heard milk called a complete food, right? Well, that's not just some clever marketing line. It's totally true. Milk is one of the very few things in nature that has literally everything a newborn needs to not just survive, but to thrive. And that right there is the key to its rich and complex chemistry. So to really get a handle on milk, you can look at it from 3 different angles. Biologically, it's all about one thing: nourishment. Commercially, it's a product that has to meet specific legal standards, for things like fat content. But chemically, and this is where it gets really cool, it's this amazing mix. Think of it like this. You've got these tiny little fat globules just floating around. That's an emulsion. Then you have protein particles kind of hanging out, suspended in the liquid. That's a suspension. And you've got sugars that are completely dissolved. That's a solution. All of this is happening at once, inside water. It's a 3-in-1 special. Now, here's something that might surprise you. Cow's milk is actually about 87% water. But the real magic, the real action, is happening in that other 13%, what we call the solids. That small slice is where you find all the good stuff: the fat, the protein, the lactose, the minerals that make milk a nutritional powerhouse. The water is really just the vehicle carrying all that precious cargo. Okay, so if milk has this basic formula, why isn't all milk the same? Cow's milk is different from goat's milk, which is different from human milk. So let's explore the incredible diversity of this seemingly simple liquid. Just take a look at this. This table really shows you how different milk can be. Buffalo milk, for instance, is super rich. Look at that, over 7% fat. But now look at human milk. It's way lower in protein, but it's packed with lactose. And that's no accident. Lactose is a type of sugar that provides crucial energy for a baby's rapidly developing brain. It's a perfect example of how each type of milk is perfectly tailored, perfectly designed for whoever's drinking it. It's evolution right there in a glass. So what's causing all this variety? Well, as we just saw, the species and the breed play a huge role, but it goes so much deeper than that. For any single cow, its age, what it ate for lunch, the time of year, even its health, all of those things can change the milk it produces from one day to the next. It's a truly dynamic, ever-changing fluid. Now, all this natural variation presents a massive challenge for the dairy industry. How on earth do you take a product that's natural, perishable, and inconsistent and turn it into something that's safe and reliable for millions and millions of people? This is the huge puzzle that dairy science had to solve. How do you take this natural, constantly changing product and make it safe and consistent for an entire country? The solution, as we're about to see, was a complete and total game changer. And the answer came in one word: pasteurization. Yep, named after the man himself, the legend Louis Pasteur. The idea is actually pretty simple, but it's revolutionary. You heat the milk just enough to kill the dangerous bacteria, but not so much that you destroy its taste or nutritional value. This single process is what made milk a safe staple food for, well, everyone. And this is the workhorse of the modern dairy, the high-temperature, short-time, or HTST pasteurizer. Now, it might look like a crazy maze of pipes and plates, but it's an incredibly efficient system. Raw milk comes in, it zips past these hot plates to get heated up, it's held at just the right temperature for a few seconds, and then, bam, it's immediately cooled right back down by passing next to cold plates. This continuous flow is what allows us to safely process huge amounts of milk every single day. So it all comes down to this super quick 3-step dance of temperature and time. First, you blast the heat, getting the milk up to 72 degrees Celsius. Then you hold it there for a very precise 15 seconds. That's all it takes to kill the bad guys. And finally, you immediately crash cool it right back down. That speed is what's so important. It preserves the quality and taste of the milk while making absolutely sure it's safe to drink. But hold on, safety is only half the battle. Once the milk is free of harmful bacteria, how does the dairy guarantee its quality? How do they make sure you're getting what you paid for? This is such a critical question. With a natural product, there's always a risk that someone might try to cheat the system. Most commonly by adding water to increase the volume and make more money. So how do we check for that? Well, the answer, once again, is some pretty simple and clever science. Dairies and food safety regulators rely on a whole bunch of simple but really elegant tests to protect the integrity of our milk. We're not talking about high-tech genetic sequencers here. We're talking about tests based on the fundamental principles of physics and chemistry. And one of the most classic tools for the job is this thing right here, the lactometer. I know, it kind of looks like an old-fashioned thermometer, but it's actually designed to do one simple thing: measure the density of milk. And that simple measurement can tell us an awful lot. So here's how it works, and it's brilliant. You pour a milk sample into a cylinder. You gently float the lactometer in it, and you just see where it floats. See, because milk is full of all those solids, the fat, the protein, it's denser than water. So the lactometer will float at a specific standard level. But if someone has added water, the milk becomes less dense, and the lactometer sinks lower in the jar. A reading below that standard line is a dead giveaway that the milk has been watered down. It's a simple, fantastic piece of science in action, protecting every single one of us. So there you have it. From a complex biological fluid to the high-tech process of pasteurization to the simple science that ensures its purity, milk is so much more than meets the eye. The journey from the farm to your glass is a truly remarkable story of science and innovation. So the next time you pour a glass of milk, maybe you'll see more than just a simple white liquid. Maybe, just maybe, you'll see the marvel of chemistry and engineering that's really in your glass. Thanks for watching.